Solutions appear colored because they absorb light at particular wavelengths in the visible spectrum. This property can be used to follow reaction where either the reactants or products are colored and therefore absorb light. Colorimetry is used to quantify the absorbance of a solution. It involves the use of a colorimeter to select a range of wavelengths where the absorbance of the sample is known to be greatest. By measuring the amount of light emerging from the sample and comparing this to the light entering the sample, the absorbance by the sample solution can be determined. In a colorimeter, light of a selected color is shown through a sample solution. Some of the light is absorbed by the sample, and a detector is used to measure the intensity of the light that passes through. The absorbance is calculated as the common logarithm of the ratio of the intensity of light entering the sample to the intensity of light leaving the sample. This absorbance is directly proportional to the concentration of the chemical species in the sample that is absorbing the light. We can use this as a way of measuring the concentration of solutions. In colorimetry, the sample solution is contained in a sample cell called cuvette. A cuvette for visible light absorption measurement is either made of quartz or plastic. Hold a cuvette by the non-transparent side. The transparent side must be clean and not be touched, because light will pass through these two sides for absorption measurement. Turn on the colorimeter and allow it to warm up. Select the wavelength at which the sample substance gives the maximum absorbance. First, several known concentrations of a certain standard are prepared to construct a calibration curve. The blank that contains all chemicals except the light-absorbing species is poured into a cuvette, which is then inserted into the sample holder of the instrument. Note that the transparent side of the cuvette should face the light source and the detector. Set the reading to 0, then remove the cuvette and clear the content. We can now measure the absorbance of each of the known concentrations of the standard prepared. Note that the absorbance measurements should be done from the most dilute solution to the most concentrated one. Rinse the cuvette with the most dilute solution 3 times. You may wipe the transparent windows with non-abrasive tissue paper moistened with spectral-grade methanol to remove contaminants. Now measure the absorbance of the solution and record the reading. After that, clear the content and rinse the cuvette with the next solution to be measured for 3 times. Measure and record the absorbance. Repeat the procedures with the remaining concentrations of the standard solutions and finally the sample solution whose concentration is to be determined. From the absorbances obtained for the known concentrations of the standard prepared, a calibration curve can be constructed. From the curve, you can read the concentration of the sample solution that correlates to the absorbance obtained.